312. Calculate the value of k so that this geometric series adds up to 98,301. Right? What do we need to do here? We can find our first term, second term, third term. Then T1, so we say 3 over 2, then 2 to the power 1, which will give us 3, right? T2, which is 3 over 2, then 2 to the power 2, then this will give us 6. Then T3 is equal to 3 over 2, 2 to the power 3, and then 2 cubed, that is 8, 8 divided by 2, that is 4, 4 times 3, that is 12. So it means our series is actually 3 plus 6 plus 12. It goes on like that, right? So from here we have our a value. So a is equal to 3, and then r is equal to 2. From 6 divided by 3, 12 divided by 6. Another important thing that we need to know is the value of n. Remember, from sigma notation, n is equal to top value minus the bottom value plus 1. So it means n is equal to k minus 1 plus 1. So basically, our n is equal to k. Okay, this is very, very important for us, right? And then let's use our formula. Remember, Sn is equal to a, and then r to the power n minus 1 over r minus 1. We want to find the value of k. So this is equal to 98,301. Right, let's substitute what we have. Our a is 3, and then 2 to the power n minus 1 over 2 minus 1 is equal to 98,301. Right, 2 minus 1 is 1. So basically we're remaining with 3 times 2 to the power n minus 1 is equal to 98,301. Then we divide by 3 on both sides of the equation. 2 to the power n minus 1 is equal to 32,767. Then we add 1 on both sides of the equation. 2 to the power n is equal to 32,768. Right? We can change from exponential form to log form. So n, the exponent becomes the subject. N is equal to log, then the base is 2, and then our argument or the number 32,768. Then you put this in the calculator, use this function. In the calculator, you can use this. Okay. Or you can say log 32,768 divided by log 2. Right. You will get your 15. Okay. From this, we get that n is equal to 15. Okay. The other thing we could have done is to say this point here, then 2 to the power n is equal to 2 to the power 15. Remember finding the value of k, but at this stage here, we know that n is equal to k. So therefore, k is equal to 15.